today I'm going to be talking about optimizing an area using some basic calculus principles. This is the question, you can read it over kind of quick. I'm just going to mention that you can use what we're going to do to maximize and minimize different, say minimizing the distance or maximizing an area or volume. As you can see, our question is we're going to maximize an area fenced in enclosure using three sides. We have a river for one of our sides, which doesn't contain a fence portion, but the total fence is 2,400 feet length. So we're going to find the dimensions to maximize our area. This is just a rough, you can see the river and our size of our rectangular field. And since it is rectangular, we can assume that the depth of the two sides coming off the river are the same. We'll call those x, and then the width of our field is going to be y. And you know the area formula is just length times width, or x times y in our case. What we're going to do to maximize it, though, we need the area to be in terms of just one variable. So we're going to use the perimeter function. And we know that our perimeter is 2,400 feet, that's just the length of our fence. And recall that's kind of what our diagram looks like with our x's and y's there. And remember, there's no fence along the river. So our perimeter then would be 2x plus y equals 2,400, the length of our fence. I'm going to let Brandon finish it up here.
So when we have the perimeter area, we get the function of 2x plus y equals 2,400. And we just rearrange our equation to make it equal to just y itself. So we just put y equals 2,400 minus 2x. And so since the area equals x times y, we're going to plug y back into it. And so the area that we get is 2,400x minus 2x squared. So to compute the derivative, we just take the basic principle of what a derivative is, and we get the following, in which the area prime, right, will equal the following equation. And thus, when we get the following equation, we're going to get area prime equaling 2,400 minus 4x. And now, when we want to maximize volume, we want to say equals 0 so that we find out what the max value of x is going to be. And so we find out that x is actually going to be about 600. Okay, so when that happens, I can just plug back into x for the equation of y. Remember, y is our perimeter equation here. So y equaling 2,400 minus 2x, I plug in back in that number of 600, and thus I get y equals 1,200 feet. And so when I take the two numbers of feet, right, I get the dimension of feet squared. Feet times feet equals feet squared, right? So the area will equal 7,200,000 feet that covers for the maximization of area. Thank you. Any questions?